Scientists have shown that older bees, which usually forage outside the hive for food, tend to have larger brains than do younger bees, which usually do not forage but instead remain in the hive to tend to newly hatched bees.
All right, so what's going on there? Tell me that in your own words.
Older bees go outside for food, and younger bees stay inside for food.
Yes. And what else? What else about the older bees?
They have larger brains. Uh,
Yes. Awesome. Okay, so keep going.
since foraging requires greater cognitive ability than just tending to newly hatched bees, it appears that foraging leads to the increased brain size of older bees.
Awesome. What's our conclusion here?
The since sentence, it
What?
appears.
Yes, it appears. Yep, because since is still part of our support. Awesome. All right, so this is a weekend question, right?
Mhm.
So we're trying to weaken the idea that foraging leads to the increased brain size of bees. So we're trying to say that foraging does not lead to the increased size of older bees, brain size of older bees. What kind of flaw do you see in this argument?
These are so hard for me.
This is this I struggled with this flaw until I finally, I don't know, I had an aha moment and I started seeing it everywhere. Does anybody know what kind of flaw is going on?
The correlation, causation.
Yeah, correlation causation. So it's weird to see this one sometimes, but it's anytime we have two things that happen at the same time, we don't just get to assume that one is causing the other. What is this argument assuming that is causing the other? We're assuming that foraging is what's causing the brain size, right?
Mhm.
But what could also be true that we don't consider? Like,
Like time, maybe? Not sure.
so okay, so you're super okay. So we're saying that foraging um leads to the increase of brain size. Well, how do we know that it's the foraging that's leading to the brain size and that the brain size isn't what's causing them to forage? So just that's the big thing on correlation is how the thing whenever we see correlation causation, we have to ask ourselves, how do we know that there's not something else that's causing both of these things? Or how do we know that it's A causing B and it's not B causing A? So if I was going to weaken this, I would want to weaken that correlation causation. So what so let's start with A. So what go ahead and read A, Brittany.
Bees that have foraged for a long time do not have significantly larger brains than do bees that have foraged for a shorter time.
Why is that one wrong?
Um, because it's not really weakening the fact that they have bigger brains, like from foraging.
Yeah, we don't care that they're significantly larger either. And that doesn't weaken it. Bees that have foraged for a long time do not have significantly larger brains. Like, but they still could be bigger. So yeah, A's wrong. All right, Anna, go ahead and read B.
The brains of older bees that stop foraging to take on other responsibilities do not become smaller after they stop foraging. That doesn't make they still have bigger brains if it's still.
Yeah, like just because they stop forage, that almost strengthens. I think B almost strengthens it.
Yeah.
Honestly, it strengthens that weak correlation. All right, what about C? Kamani.
Those bees that travel a long distance to find food do not have significantly larger brains than do bees that locate food near the hive. So that wouldn't weaken it.
Right. Does it matter how far they travel, or are we just saying that foraging leads?
Yeah, it doesn't matter like the distance. It's just
Yeah, so that's not helping us at all. All right, Ashley, go ahead and read D.
In some species of bees, the brains of older bees are only marginally larger than those of younger bees.
I feel like D's a little bit tricky for some people, but why is D like a pretty, like, why are we hesitant of D right away?
It's the some species. maybe.
Yeah, so this is a very, very mild. So at least one. And it's like, well, that doesn't mean that this isn't happening. All right, and then go ahead and read E, Ashley.
The brains of older bees that never learn to forage are the same size as those of their foraging counterparts of the same age.
Why does that weaken our answer?
So now I think I see it. So it's saying that just because like your size, regardless of your size, it doesn't matter. Like I can't explain it.
Okay, so this is saying that it's not the foraging that leads to the increased brain size. What might it be instead?
It could be the size.
Not well, there I think we're agreeing that their brain sizes are different, but where this is what E is saying is essentially what this is leading to is it's not that foraging is changing the brain size. What is changing the brain size?
Their age.
Their
Their
age, yes. So what Ashley, what this one is saying is the brains of older bees that never forage are the same size as those that did forage of the same age. So they're saying like we have these two groups, group 1 and group 2. Group 1 never foraged, and this was their brain size. Group 2 did forage, and this is their brain size. So it's saying like, hey, it's not the foraging that changed the brain size. It's just that as you get older, your brain gets bigger. So for a correlation, we would go here and say like, hey, we assumed that it was foraging causing the brain size, but really it was this other thing. All right, anybody want